Good
Yes,
afternoon, sir.
good afternoon, sir.
Yeah, good afternoon, dear. Fine, let's get started and get done with the portion that we are left with in fluid today.
So
Right
before
now,
starting, I just wanted to ask you, so the Allen test, right? So it's on a JEE mains pattern. So I really don't know how the pattern is. I've never been briefed
means
before.
is objective. One option correct.
And
Only one
marking.
option correct. Marking either correct. You are the only one option correct. There is no
So
question
like a
of
negative marking or how much for
there
negative
is
marking?
negative marking. There is 0.251 by 4 negative marking. But they are talking of means pattern, right?
Yes, sir.
So it'll be -1. Negative. Okay. It'll be negative marking. So you need to make guesses, but be sure of making smart guess. Can
Yes.
take calculated risk, but ensure that it is calculated because all your hard work will go down the drain if anything goes wrong on question. Okay. Suppose one
Yes.
question you have toiled hard and got the answer to, and another you take a chance. So all your work goes down the drain. Correct? Yeah.
Yes, sir.
Take intelligent guesses and accordingly do mark. But I'll ask you to refrain from even intelligent guesses. Initially, when you are solving questions, then you should be sure of the answers which you are getting. If you aren't sure initially, there is some lacuna that you need to fix in vis-a-vis theory. So initial taking chance, I don't subscribe to. Later, when you are done with the portion and you are writing on D-Day the examination, there is when you can exercise some laboratories. India.
Yes, sir.
Okay. So what do we have for the day? I'm to upload today. This goes to all of you. I'm to upload today. If I'm able to take those questions in class, good. If I'm not able to, then I'll be uploading few questions today, which you will solve in stipulated time, which I'll mark and revert. So please let me know of your time, which should be all in consensus with, so that I can upload and get from you in a span of around 20 to 25 minutes. Approach to those questions. Correct, yeah?
Yes, sir.
Yes, sir.
Okay. Okay, so let's get started with the portion and write a few theoretical part which we are left with. A, write down. Siphon. Siphon. Given a siphon. Given a siphon as shown in the figure. Given a siphon as shown in the figure. Find equation for it. Find equation for it. Operation. Given a siphon as shown in the figure. Find equation for its operation. So there's a siphon shown in figure. You have to find equation for its operation. This is what I mean by siphon. You must have try suck out liquid from, let's say, a cola bottle, a juice bottle, a juice pack, or for that matter, if at all you have an anecdotal experience of taking a tube and trying to suck petrol or let's say water from one vessel to the other vessel, if you want to just through a hollow pipe, if you want to let water flow from one vessel to the other vessel, if you have any anecdotal evidence of the same, then you must have seen that you have to maintain certain equation between two containers. Only then is possible for the flow to be sustained for some while. And as liquid goes drained from one vessel, there is time or time and again I'll say you'll have to adjust the levels to maintain flow. If you're not, then flow will cease to take place after some time. Have you ever had tried to pour some from one bucket water through pipe to the other bucket? Any one of you?
Sir, so
With the help of a pipe, did you try to suck liquid from one vessel and pour it through pipe to the other vessel? Have you ever channelized it?
yeah, I've tried that.
You have tried. Okay, so if you have tried, Krish, then you would have, I think it must be imperative on you to recollect what was your experience.
So
Was it
like,
that once the flow got established, it is to be there till the time one of the bucket got drained, or you had to intermittently change the position?
so you have to change position.
Yeah, change the position to maintain flow, correct, dear?
Yes, sir.
So we are trying to study for the reason why we have to change position. Fine, dear?
Yes, sir.
In siphon topic, what we'll learn about is the operation of siphon and at the same time, what is required for sustained flow of liquid to be maintained. Is it okay?
Yes, sir.
Fine to all of you?
Yes, sir.
Okay, so this is a vessel taken, all of you. And there are a few points which I am enumerating over here. Please be careful of those points. It's a very narrow tube. In want of you being on your visibility not marred, what I am to do is I am to show you with a gauge, but this is very narrow. Is it okay of all of you?
Yes, sir.
Yes.
With gauge, though, I have prevaricated it being very narrow. This is what this structure is to us. It is visible to you, kind of U-shaped structure, all of you. Not the vessel, not water. Just the U-shaped structure. Is visible to all of you?
Yes, sir.
This U-shaped structure is what is being given name of siphon. Is it okay? This is what
Yes.
is called siphon. Clear to all of you?
Yes,
What I
sir.
call this a siphon. Idea.
Yes, sir.
Okay. Now there are a few points which I have to show you over here. And as I've told you, please be careful of those points. I'm to show you a point over here. Out of siphon. Is it okay? Out of siphon, but very close to surface. Visible, all of you?
Yes, sir.
Out of siphon, very close to surface, is being marked 1. At the same level, but inside of siphon, being marked 2. At the same level, but inside of siphon, being marked 2. Then we have third point. Third point is just above the level, and is being marked 3. Visible, the pink color chalk piece?
The third point I'm not able to see, sir.
Okay, fine, fine. I'll change the color of it. The orange I'm using now. Let's see. Try to make it visible to you. Third point is this, Krish. I am marking it by orange color chalk piece. Is it visible, Krish? No.
Yes, sir. Now, so within
Visible,
the
Krish?
siphon, yes, sir. Within the siphon, no, sir.
Yeah, within the siphon. Third is inside of the siphon.
Yes, sir.
Okay. So these are the 3 points which I have shown. Now I move to the fourth point. Fourth is over here at the top. The fourth point. Okay. And to the level of liquid here, you have fifth point. And now from where liquid is to squirt is 6 to us. Visible to all of you, all the points. Please
Yes,
continue
sir.
it.
Yes, sir.
Is the board fine or is glazing?
No, sir, it's fine
It's
now.
fine. So could you just move your camera to a bit down? The entire board is not visible.
I'll try. Actually, I try to set it up. It's difficult to ask, but I'll try it. Is it visible now?
Yeah.
Yes,
Yeah.
sir.
Okay. Okay. So this being the case, what we are to find is using Bernoulli's equation. What will be energy equation for all the points? Is it okay? There are altogether how many points, class, for you to see? There are 6
Six.
points for you to see, correct? Yeah.
Yes, sir.
Yeah.
For all these 6 points, for all these 6 points, what I'm to do? I'm to write Bernoulli's energy equation. Find here.
Yes, sir.
Yes, sir.
Yes, sir.
All of you, please respond. For
Yes,
all these 6 points, we are to write Bernoulli's equation of energy. Find here.
Yes,
yes,
sir.
sir.
Okay, good enough. Let me ask you on 2 points out here. Out of the 6 points, I am asking, positioning my question to 2 points. And they being 1 and 2. Find here.
Yes,
So my
Yes,
first
sir.
Yes,
thoughts
sir.
being positioned on 2 points, 1 and 2, right, Adesh?
Yes, sir.
And I wish ask, what according to you will be velocity relation of the points 1 and 2? What according to you will be speed relation between points 1 and 2? Am I clear on my question?
yes, sir.
Okay, they are to move as liquid is being siphoned, isn't it? Liquid will get siphoned. I'm assuming that liquid is getting siphoned. Fine, yeah?
Yes, sir.
Yes,
So the
Okay, yes,
speed
sir.
of
Liquid is
will be
getting siphoned. You are ought to see level of water in this change, right? Yeah.
yeah, yes, sir.
Yeah,
It is to
yes, sir.
siphon level of water in the trough or vessel taken by us is to change. So yes or no, dear?
Yes, sir.
It's
yes,
to change. Yes, sir.
The area being in your know, you can say that though the level is changing, but it is changing at snail speed. Can we say that? I told
Yes,
you
sir.
this is narrow, so much so that you can neglect the thickness per se, assuming it to be wafer thin. It may not be visible to naked eyes. If I'm to take it to the ideal case, I'm talking the state where it will not be visible, distinguishable by naked eye. Is it okay?
Yes, sir.
yes, sir.
Yes, sir.
That narrow is the gauge, and from here you are to gauge on what will be the speed of squirt and speed of level change in vessel. I think you have the acumen to gauge on it, correct? Yeah.
Yes, sir.
Yes, sir.
And we say
Yes,
that
sir.
the level will descend. Of course, it is to descend, it is to recede, but it will recede with snail speed, correct? Yeah.
Yes, sir.
Yes,
Yes, sir.
Okay. So with that at the backdrop, with that understanding at the backdrop, let me ask you on points 1 and 2. How you relate speed of particle 1 with particle 2. Think about it and come up with something. We want deliberation class. Physics is a dud without deliberation. So it's not about you going wrong or right. You need to speak your mind. Correct, yeah?
Yes, sir.
Okay, so please deliberate and let me know what comes to you on relation between point 1 and point 2 vis-a-vis speed.
So, if
so the
P1,
speed
P1
of
will be,
two,
One at
so
a
the
time, please. Yes, Krish?
sir, P1 will be equal to P2, no, sir? Because it's
P1,
at the
I
same.
don't know, Krish. I don't know about P1, P2. We'll talk about it later. But
Okay, sir.
something can be commented on speed of
If
particle 1 and 2.
the
Either
speed
you
of
say it is equal or you say 1 will be greater than 2 or 2 will be greater than 1, whichever.
the 2 will be greater than 1.
Okay, yes, Vedant, you are saying
yes,
something?
sir. Yes, I was saying that two will be greater than one.
Okay, Adesh, what say you?
I, I don't know.
Okay, yes, I told you, speak your mind, dear. There's nothing to lose
Sir,
out here.
I'd say, so P point. So I'd say both of them will move with the same velocity.
Okay, you're going with same. Okay. Yeah, Pratyush, what about you?
So 2 will be greater than 1.
Okay. Okay, fine. Now, so I think this is speaking volume of you have never tried it out. This is speaking volume of my student having not a hand-on experience on this. Why? Why I'm saying so? Look at 1 and 2. All of you, please look at 1 and 2. Are they not part of bulk?
Yes, sir.
They are both part of bulk. Can I say that? When I
Yes,
say
sir.
bulk, what I mean that, okay, we are not novice to where 2 is. We are not ignoramus of 2.2 position. Nobody is over here ignoramus to it. We can see that 2 is over here inside of the siphon and 1 is out of it. But one thing which we are sure of, all of us are sure of, being 1 and 2, they are part of bulk. Though 2 is inside of siphon, but it is very much part of bulk. Do I have your agreement on this?
Yes, sir.
Yes.
Okay. So if 1 and 2 both are part of bulk, then they are ordained to move with same speed, which is what Adesh did indicate. So see Adesh, sometime luck can run in your favor, idea.
Yes, sir.
Getting it, Adesh, you are not taking a call, getting it a skip, which you would have then got no addition to your marks, but trying out on your luck, if you are playing luck that day, then you got +4, correct? Yeah.
Yes, sir.
Okay, so never shy away from taking a try. You can. What I want to say is, if I am to take note of 1 and 2 both being part of bulk, then there is no point I am to distinguish between their speed. They cannot move with different speed. They are to move with same speed. Why? Because the bulk per se, the level per se, is to relate to one speed. Agreed, all of you?
Yes, sir.
Yes, sir.
So the level is to relate to one speed. If the area is same of the level, and if 1 and 2 are part or are encapsulated by that level, then of course 1 and 2 cannot move with speed exception to each other, right? Yeah.
Yes, sir.
Yes, sir.
So
Yes,
1
sir.
and 2 are moving with same speed. Having said that, in adherence to the precedents that we have set or the surmise that we are moving with, if I'm in adherence with the surmise and it being level is moving with snail speed, right, dear?
Yes,
Yes,
sir.
sir.
Yes, sir.
Isn't it? So if the level
Yes,
is
sir.
moving with snail speed, then will you approve of V2 being equal to V1 being equal to 0, right? Yeah. Because this is the premise we began with. Can you recollect what did I say at the top of discussion? This is the premise we began with. At the top of discussion, I told you that area of the broader vessel is very large in comparison to area of siphon. Correct, yeah?
Yes,
Yes,
sir.
sir.
Yes, sir.
In compliance with that surmise, V1 is equal to V2 that we know. And now we can go beyond their equality and mark them to be 0 each. Correct?
Yes, sir.
Yes,
Yes.
sir.
This is where we are to what makes us comfortable on it being marked 0. V1, V2 we know. From where do we get V1 will be equal to V2? Why I'm saying they are even as they are both part of bulk. Correct, yeah?
Yes,
Yes,
sir.
sir.
Yes, sir.
But what makes me add to 0? Tell me, dear. What
They're
makes
traveling with snail speed.
Because traveling with same speed is fine, but why 0? Why that speed is summing to 0?
Because area of the surface is
Correct,
large as compared to that of the.
correct, Krish. This should be distinctly clear. Please don't muddle later. Okay? Don't mix and match to get the answer. Please be distinct in what is written for what reason out here. So V1 is equal to V2 has got one reason, and V1, V2 being equal to 0 has got a different reason to cite. Correct, yeah?
Yeah. Yes, sir.
Yeah.
Yes,
Yes,
sir.
sir.
So please be clear of from where we are coming. Now, let me mark this length as H1 and this length as H2. There are a few questions incoming, so I'm forewarning all of you. Please be careful. H1 and H2 being marked. Now, we would like to use Bernoulli's equation for position 1. So position 1 is open to atmosphere, right dear? Almost very close to the surface.
Yes,
Can we say
sir.
that? It's very
Yes.
close to the surface, right dear?
Yes, sir.
So if it is very close to the surface, what will be pressure equation there? Can we say will be equal to atmospheric pressure?
Yes, sir.
Yes, sir.
Okay,
Yes, sir.
so pressure there is equal to atmospheric pressure. Therefore, I wrote P naught as pressure there, right dear?
Yes,
Yes,
sir.
sir.
Yes, sir.
Okay. What about rho GH if I have taken this as my zero of potential? Can you comment on rho GH? I'm writing energy equation. Let me make you privy to and assert on my point.
Yes,
I'm
sir.
writing energy equation, Bernoulli's energy equation, correct, yeah?
Yes, sir.
Yes, sir.
So we can start with P1 plus rho GH1 plus half rho V1 square, correct, yeah?
Yeah, yes, sir.
Yes, sir.
Yes, sir.
One being close to atmosphere, very close, there is just a film as distinction. We can say P1 will be equal to P naught, agreed or not?
Yes, sir.
Even if the film is a distinction, but the film is not flat, we cannot make the same comment. Please recollect yesterday's class, before yesterday's class. Here, if this is the curvature, this is 1 and this is open to atmosphere. Can you say P1 will be equal to P naught?
No.
See,
No.
the
No, sir.
distinction is just the film. I want to make every part clear. Distinction is film over here, distinction is film over here as well. But film over here is flat and film over here is curved. Distinction is the same, wafer thin. What I ask is, can I say in this case, P1 will be equal to P naught? These are few questions, class, coming your way. Can you
No,
say P1 will be
No,
equal
sir.
to P naught in this case? Yes
No,
or no?
sir.
no,
No.
no.
No, sir.
Be higher here. Which one will be higher here?
P naught.
The P naught will be
P naught.
higher.
Got it, dear?
Yes,
Yes,
sir.
sir.
Okay. Can I say over here that P naught will be equal to P1?
Yes, sir.
Yes,
Yeah,
sir.
yeah.
You
Yeah,
can,
yes, sir.
correct? Yeah. Why? Because the surface is flat, right?
Yeah. Yeah.
Yes, sir.
So we
Yes,
can
sir.
say P1 will be equal to P naught, and that is the understanding we are coming from. I have taken P1 equal to P naught. Any objection, any one of you?
No,
No,
sir.
sir.
Okay. Now, what about rho GH? Rho GH1. Rho GH1. That depends on
So
zero of
zero.
potential chosen by
Yeah.
us, correct? Yeah.
Yeah.
Yes, sir.
Yes,
Will
Yes,
be zero.
This to be our zero potential. So we can go ahead with it being zero, correct?
Yes,
Yes.
sir.
Very
Yes, sir.
good. And the last one, howsoever small, yet there is a value. So I'm beginning with rho V1 square. I'm keeping it as rho V1 square. Fine, yeah?
Yes, sir.
We'll see
Yes,
it later
Yes,
what it
sir.
shapes to. Later what it shapes to. For now, I'm keeping it intact. Okay, dear?
Yes, sir.
Yes, sir.
Okay. Could you please help me with 2 as well? Can I
Yes,
say
sir.
pressure at 2? And please be careful to this question. Can I say pressure at 2 will be equal to P naught? Can I say pressure at 2 will be equal to P naught? I don't
No,
know.
sir.
No, sir.
Oh, yeah. No.
No, sir.
Okay, if we are not very sure on it, I'll keep it as P2. P2 you are all good with, correct here?
Yes, sir.
Yes, sir.
Okay. And then potential energy also you are all known to 0, right here?
Yes, sir.
Yes, sir.
And then I go to half rho V2 square, correct here?
Yes, sir.
Half
Yes,
rho V2 square. Okay. And Adesh was vocal about it being not the same, P2 being different, which over here got substantiated. I'll come to it, but I'll come to it later. Tell me for the relation V1 and V2 that we have read. What about V1 and V2?
So
Are
there's
they
0.
same or different?
Equal and 0.
So equal and
0.
0.
Equal and 0. And if I'm going by Bernoulli's equation, then I know any equation can be equated to the other, right?
Yes, sir.
Yes, sir.
Can equate one equation to the other. Say me yes or no, all of you. Please be loud.
Yes, sir.
Yes, sir.
Yes, sir.
If I'm equating first with second, and we are of an understanding that V1 is equal to V2, then I suppose we get P naught is equal to P2.
P2. Yes, sir. We get.
Yes.
Are we getting it or not? Please try to reason it out. Is it okay? Are we getting it or not?
Yeah, yes, sir.
You're getting.
So I presume we will say P2 will have the same atmospheric pressure what is experienced by P1 owing to level being same and it being part of bulk. Correct, yeah?
Yes, sir.
Yes, sir.
Yeah.
I change level, of course, pressure will change. But if level is maintained and they are part of bulk, then P2 cannot be an exception to P0. There cannot be any distinction, right, dear?
Yes, sir.
Yes, sir.
In that it is falling. In that case, we are going with they being same. Let us move to P3, all of you. Shall we move to the point 3 now?
Yes, sir.
Yes, sir.
What is your take on P3? Will P3 also read same pressure? Because
No,
3
sir.
and 2 are very close to each other. The only distinction being fill.
Yes, sir.
Means what I want to over here go exclusive on is 3 being part of siphon more than bulk. Can we say that?
Yes, sir.
You will relate to 3 siphon more than the bulk. Yes or no?
Yes, sir.
Yes, sir.
Yes.
So with that distinction, what is your take on P3 pressure at 3? Will it be even with P0? Will it be even with P2 or should be different?
So it should be different, no, sir,
Different.
because different, yeah.
Okay.
Yes, sir. Different.
Okay. So all of you are subscribing to it being different, correct? Yeah.
Yes, sir.
Okay. And if it is different owing to
So because the area is small, so the film there will form a curved surface because being the liquid will form curved surface. So that means we cannot.
I'm not taking that into account, Krish, for now. I'm not taking the liquid surface into account, Krish. You know why? Because it is a flow. And when water or any liquid is in flow, then you are not privy to meniscus, correct, dear?
Yes, sir. Okay.
Yes, sir.
Meniscus you will be privy to only when it is stationary. Are you getting my point?
Yes, sir.
So I'm
Yes,
not
sir.
privy to meniscus. I am not to relate it with static pressure. If at all I were to relate it to a static pressure equation, I would have gone ahead with Bernoulli's theorem, right? Yeah.
Yeah. So, but then in this case, if there is flow, should be there. That means there must be pressure gradient. So that means water always flows from higher to lower pressure, no, sir. So that means there must be a pressure gradient, so it will not be equal.
That's true, but the same holds good for point 1 and 2, Krish.
Yes, sir.
Right, dear? From 1, it is going to 2, right, Krish?
Yeah. Yes, sir.
Yes, sir.
Yes or no, Krish?
Yes, sir. Yes, sir.
So if from 1 it is going to 2, then I don't find any logic which can stand my answer. I cannot find any logic which can stand my answer of liquid flowing from 1 to 2. Why? Just now we got even they on pressure, correct? Yeah.
Yes, sir.
Yes, sir.
So there is more than what meets the eye. There may be some reason for flow. I will come to that reason of flow, because that's the purpose of this siphon engagement, and that being, I have deployed this siphon for a purpose. So flow is to be maintained, but there can be few things in coming. For now, if we are whatever at, if we can limit ourselves to and ask ourselves that liquid is having some pressure gradient, must be having, of course, some pressure gradient for flow to be maintained. But I'm oblivion to that part. I'm with blinkers on. I'm to just look at point 3 and ask myself, is point 3 to share pressure with 2 or P naught? To which what you are to say, no. I have taken that answer, accepted that answer. Yes, of course, pressure is different. But I cannot take the reason what you're citing, Krish. Correct, dear?
Yes, sir. Yes, sir.
So if you could limit it to what we have studied and tell me, why will pressure be a differential to 2 or P naught? Anyone? Why will pressure at 3 be a differential to 2 or P2 or P naught? As P2 is equal to P naught, you all know now. Come on, you can cite a reason. Yeah, equation is there with you. Can you get me Bernoulli's equation for point 3, all of you?
Okay.
Tell me.
Yes, sir.
V3
P3 plus
plus rho GH, which is 0. Can we?
Zero.
H is again 0.
Yeah, so it will be 0.
The only distinction is the film I told you. H is again 0. Adesh,
Yes,
right? Yeah.
0. Yes, sir, 0.
So 0. And plus
Plus half
half
rho D3 square.
rho V3.
So
Now
this one we
tell.
can equate P2.
Tell me, come on.
So
Yes.
we can equate this to P2 because rho V1 square is anyway 0. So
Yeah.
rho V2 square is 0. So
What about V3, Krish? You are not coming to the moot point, which is what I wanted to get from you. That's the reason I'm trying to appropriate words to you. What about V3, Krish? Come on, say something about V3, yeah.
the V3 will be this
Can
one.
you say V3 will be equal to V2 or V1?
No.
No.
So I told you 3 cannot be related to bulk. It is more to be related to siphon than to bulk. Didn't I tell you?
Yes, sir.
Till the
Yes,
time
sir.
the portion which is dunked in liquid, bulk liquid. If you are talking of the portion of siphon which is dunked in bulk liquid, then they are to move with same speed, a given, right dear? Because
Yes,
though
sir.
they are inside of siphon, though 2 is inside of siphon, but it is to relate to bulk more than siphon, correct dear?
Yes, sir.
And I think you can gauge on what I am suggestive of. Are you able to?
So is it
Yes, sir.
because of the area of the
Yes.
siphon?
Able to decipher what I'm suggesting? I'm repeating my suggestion. Please decipher it. Please try to decode it. 2 is inside of siphon, right?
Yes,
Yeah,
sir.
yes, sir.
But 2 at the same time is part of bulk, right?
Yes,
Yes,
sir.
sir.
Yes, sir.
So 2 relates more to bulk than siphon, right?
Yes.
Yes, sir.
Yeah, yes, sir.
So 2 will move with speed which is to be governed by bulk, correct?
Yes, sir.
Yes.
Now you go beyond bulk, right dear? Where
Yes, sir.
are you? You are at 3. Is 3 part of larger bulk? What will you say? What
No.
will 3 relate to, bulk or siphon? Is
The
it part
siphon.
of larger bulk?
Siphon.
It is not part of larger bulk. Yes, dear?
Yes,
Yes,
sir.
sir.
Okay. In that case, do you feel that 3 will move with a speed equal to what 2 did, or should be different?
So it should be different.
And that difference you will get from which equation?
Bernoulli.
Continuity equation, right?
Yeah.
Yeah.
Yes. Yes, sir.
Yeah, all of you.
Yeah,
Yes,
yes,
sir.
sir.
Which equation is to hold water here? Continuity equation. If you are belonging to bulk, you will move with speed of bulk. If you are to relate more to siphon than bulk, then your speed is ought to change. And what will be that change speed? The changes of good fold, good quantum. Can I say so?
Yes, sir.
Yeah.
So V3
Yes,
will be
sir.
more.
An area being good on differential, very good distorting difference between the two areas, right? Yeah.
Yes,
sir.
sir.
Yes, sir.
If there is a more the difference, more will be the difference on speed as well. Correct? Yeah.
Yes,
Sir.
sir.
Okay. So what makes you say P3 will not be equal to P naught?
The
The
this one.
difference in area.
Equation to any equation that is there with you, and we are good with the equation. I can go with any of the two over here as an equilibrium. And if 3 is in equilibrium with 1, then what we get to see, P3 will be less than P naught, right? Yeah.
Yeah. Yes, sir.
Yes,
Yes,
sir.
sir.
As I'm assuming V1 to be 0, then P3 will be less than P naught. Can I say yes or no?
Yes, sir.
Yes, sir.
And less by what amount? If V1 is 0, then will be less by amount half rho V3 square, correct?
Yes, sir.
Yes.
Please lean
Yes.
on the information. There are many an information that you are to pick. Okay? So even if you are getting to pick on holes, please don't mind picking it. Is it okay?
Yes, sir.
Yes.
Yes, sir.
Okay, so please pick on information. Lean on information is very important for us vis-a-vis ITJ examination, siphon. Now, it is less, and less by what amount you got? Half rho V3 square. Let us go beyond this point. Let us transcend this point. Go to 4. Okay, for 4, help me write the equation, please, all of you. Start, any one of you. What visible this point?
So for
No,
what?
sir.
For which one should we write?
For point 4, Krish.
4. Okay. Yes, sir.
The point, it's not visible.
No, there on top.
It's visible. It's
P4,
visible.
Dr. P4, correct?
Yeah.
Yes.
Yes,
Plus
sir.
Okay.
rho
We
H1.
do have some read on
Sir,
potential
H1.
energy, correct?
Yes,
Yes.
sir.
Yeah. Yes,
Sir,
sir.
What will be
H1.
positive, negative? Positive, negative.
So,
Positive.
positive.
Potential and it's positive.
So plus of rho G
H1.
H1, right?
Yeah,
Yes,
yes.
sir.
Plus of rho G H1. And then we go to the kinetic head. Kinetic head will get us half rho V4 square. Someone is to cite a relation between V3 and V4. Who takes the bait? Who takes the bait?
I'll do it.
Okay. Can you cite the relation between V3 and V4? Just a relation. One greater than the other or they being equal. Come on, Krish.
Yes, sir. 1 second.
V3 and V4.
Yes.
Yes,
So,
Krish, you're saying
V4
something.
greater.
Sir, V3 is greater than V4.
Okay. Adesh, what's your take?
Yes, sir. V3 is greater than V4.
Okay. Pratyush?
Yes, sir. So V3 is greater than V4.
Okay. All are echoing. Why are you parroting one other answer? Okay. And
So,
I'm left with Vedant. What is your take?
so my take is V4 is greater than V3.
Okay. And tell me, what do you give the continuity equation to? Are you giving continuity equation a toss? Is the continuity equation to go for a toss?
So
Yeah, the
V4.
proof of pudding lies in eating. You all know very well. So just parroting continuity equation will not help. You need to be sure on application. Correct, yeah?
Yes, sir.
Yes, sir.
Okay, because it all boils down to how you apply the concepts. Remember, fine.
Yes,
And
so
that is
V3 is equal to V4, sir.
Yeah,
Like
V3
is my answer.
one is equal. If A3 area here is equal to area here, which is what I have taken. Correct, yeah?
Yes,
Sir.
sir.
Yes, sir.
Then how can we give continuity equation a toss? What will you say? Correct yourself, reevaluate, and let me know.
V3 is equal to
Please
V4.
equal to
V3 is
V4.
equal to V4.
V3 will be equal to V4, right? Yeah.
Yes,
Yes,
sir.
sir.
Yes, sir.
V3 will be equal to V4. Please keep on collecting these points somewhere. V3 will be equal to V4. Okay, good enough. Let's go to point 5 now. Point 5, dear. What about point 5? I write P5
P5
plus OGH
is
0, correct?
yes, sir. Yes,
Yes,
sir.
sir.
And what about half rho V5 squared? What will you say about V5, any one of you? Now you know.
So
Can you
equal.
cite, can you cite equality between V4 and V5?
Yes, sir. Equal.
Yes, sir. Yeah.
They
Yeah,
are
they're
equal.
equal.
Good. They
Yes,
are
sir.
equal and we'll use them later. Going to point 6. Point 6 is P6. And tell me now, what about potential energy?
So rho GH2.
Minus rho H2.
Yeah, minus 2.
Minus rho GH2. Minus rho GH2. Right? Yeah. Right, Vedant, Krish?
Yes, sir.
So
Yes,
one
sir.
small question.
Yes, yeah.
Won't P6 be equal to
Yeah.
P0?
Yes, dear. I'm coming to that, dear. I'm coming to that, Krish. That was my question in coming. Okay. Now, what about kinetic energy, kinetic head?
Half rho V6 square.
So half rho V2.
V5.
V5.
V6 or V5, they are all same as you know. You can write any, right here.
Yeah, yes, sir.
Okay. Now, I have a question, class. And the question being P5 and P0. What relation they share? P5 and P0. What relation they share? Is P5 equal to P0, less than P0, greater than P0? Any one of you, please volunteer. P5 and P0. And you can from the equations on board. It is sugar coated. It is camouflage. So I wish that you do uncover it, unveil it. Yes, Krish, you were saying something about 6 and you are known to keep it to yourself. And you can get me an answer to the question which I have asked. The question being, P5 is equal to P0, is less than P0, is greater than P0. Come on, quickly class.
So greater than P0
Greater
by
than
half
P0.
P square.
Yeah.
P5
Yeah,
is greater. Okay, can be. Okay, Krish, what is your take? Let me go individual now. Krish,
Yes, sir.
P5. Krish, am I audible?
Yes, sir. Yes, sir.
Okay,
So
P5.
it should be greater than P0.
P5
Yes,
should be
sir.
greater than P0. Okay, Pratyush.
Sir, I'm not sure.
We'll get you, Pratyush. Please come again.
Hello, sir.
Ah,
I am not sure.
okay, fine. But you all should always be open to trying to take a shot at it in the classroom, not an examination, not this time. Anyway, let me ask you, class, can I equate these two? Can I equate these two? Would you approve of equations? And if you
Yeah.
approve
Yes.
of equations, can I equate these two? Yes or no?
Yes, sir.
Yes, sir.
I don't know what made you this way, Krish, but you asked me a very pertinent question. And that being, is not P6 equal to P0? And I nodded yes to it. Correct, yeah?
Yes, sir.
I was affirmative on it. That of course P6 should be equal to P0. Why so? Why I was affirmative on the same?
So
I
because
was
it's
affirmative on
supposed
your
to.
ask owing to 6 being open to atmosphere. Correct, yeah?
Yes, sir.
So if 6.6 is open to atmosphere, then we can rewrite this to P0 minus rho GH2 plus half rho V6 square. Correct, dear? Check it out. Visible to all of you?
Yeah, is equal to.
Visible?
Yes, sir.
Yes.
And if that's the case here, then these two equations which I'm marking, also visible, all of you?
Yeah, yes, sir.
Yes.
Therefore, different points, 5 and 6, they can be equated owing to Bernoulli's equality. Correct here?
Yeah,
Yes.
yes, sir.
If they are egalitarian, which they are, and not only that, they are also egalitarian on speed, correct?
So P5 is lesser than P naught.
Okay, they are also even on speed. Can we say that? V5 is equal to V6, we are known to it, right?
Yes.
So what we get to see from here, P5 will be equated to P naught minus rho g H2. Same yes or no?
Yes, sir.
What do we get P5 as? Greater than P naught or less than P naught here?
Lesser than.
The less than P0.
Okay, so please glean on these points and write it down somewhere. P5 will be lesser than P naught and lesser by what amount? That also is known to you. Rho g H2. Clear?
Sir, but I
Yes.
have a question. Sir, if
Yes.
water has to flow from 5 to 6, so going by that logic, won't
Mhm.
P5 have to have a higher pressure than P6?
Water is to flow from 5 to 6, right, Krish? And water flow is to be maintained with higher pressure. You're fine, absolutely correct on it. So when you're talking of pressure, you are calculating pressure from which point? You are calculating pressure from this point, correct?
Yes, sir.
Okay. Now this is open mouth. Here you are getting P naught. And this equation is suggestive of P naught being greater than, right? Yeah.
Sir.
That is
Yes.
your objection, correct?
Yes,
Your
sir.
objection being, I am getting P naught being greater than P5 and greater
Yes, sir.
by what amount? Greater by rho GH2. That's your question, correct, Krish?
Yes, sir.
Now tell me, Krish, if I have water and I'm pouring it from some height,
Yes,
okay,
yes, sir.
water descends. Water descends. As water is descending, why water is descending can be owing to two reasons. One, pressure, the other,
Gravity.
pull by atmosphere,
Okay. Yes,
gravity.
sir. Yeah.
Okay? One by pressure, of course, the other pull by gravity, atmosphere, correct? Yeah, the
Yes, sir.
ambient.
Yes.
So can I discount on the pull due to gravity?
No, sir.
Also.
Student
When
won't.
we are to, if we are maintaining level and we are talking of there being a flow maintained, then we can be absolute on it cannot be maintained if pressure is not to change. Pressure must change. I'm speaking. Why only water? I'm speaking. I'm changing pressure right here. You will study this in wave. And that pressure is moving from higher zone to lower zone. Correct, dear?
Yes, sir.
Yes.
So it goes the same for every element that you are referring to. But we cannot be dismissive of gravity. Correct, dear?
Yes, sir. Yes, sir.
So that can be owing to gravity. I have to take gravity into account as well. And second point, Krish, which also is of great import. Why are you equating 5 with 6? Why can't I equate 4 with 6? What if I say, Krish, that 4 also is at a pressure lower than 6, which we'll be proving in 2 minutes from now. That 4 can be lower than 6. That is also possible. As 5 is lower than 6, 4 will be all the more lower than 6, you know.
Yeah. Yes, sir. Yeah.
Yet water will flow. And that's the reason, Krish, why you are to maintain height. Getting my point?
Okay. Yes,
Else,
sir.
else, if pressure difference was the only reason, once established, it was to continue flowing, correct?
Yes, sir.
It doesn't happen. Okay?
Yes, sir. Yes, sir.
So let us now move on to the other points and ask ourselves, what about P3 class? P3 and P5. Can you tell me the relation between P3 and P5? They are same, one being greater than the other. P3 and P5. Now you know it's almost that we are into replicating. I expect all of you to get me an answer. P3 and P5, what relation they share?
Sir, it will be P5 is equal to P3.
Okay, and this is coming from V3 being equal to P5, right? Yeah.
Yes, sir,
Yes,
yeah.
sir.
P3 being
Yes, sir.
equal to P5 as the area same for cross section. P3 will be equal to P5, right? Yeah.
Yes, sir.
And P3 if is equal to P5, then we can say P3 is also less than P0 by rho g H2, right? Yeah.
Yes, sir.
Okay, all getting untangled. All of you, is it
Yeah.
clear?
Yes,
Yes,
sir.
sir.
Yes, sir.
Okay, fine. Good enough. Good enough. We are unfolding it bit by bit. Good enough. P4 now. Let me
So,
come to P4. Let me come to P4 and ask you, what can you say about P4 vis-a-vis, as Krish was asking for 6. So let me take 6 only. What can you say P4 vis-a-vis P6?
so
What
less.
we say about P4 vis-a-vis P6? Now, for P4, which equation is valid is known to you, right? Yeah.
Yes,
Yes,
sir.
sir.
And for P6, is this valid, right? Yeah.
Yeah.
Yes, sir.
And we are of the understanding V4 being equal to V6, right? Yeah.
Yes,
Yes,
sir.
sir.
So what do we get? Tell me.
So
What
it
do
will
we
be
get?
So
less.
the P4 is equal to P6 minus rho g H2 plus H1.
P4 is equal to P6, which is P0, right, Krish?
Yes. Yeah.
Yes, sir.
Minus of rho g H2 there.
Yeah.
And this H1 goes to that side, so minus of rho g H1 as well. Correct, yeah?
Yes,
Yes,
sir.
sir.
Now see for yourself, Krish. It is all the more compounded. Correct, yeah?
Yes,
Yes
sir.
or no, Krish?
Yeah. Yes, sir.
Okay.
Yes, sir.
So H1 plus H2 is what we are getting. P4 is equal to P0. Very important equation this class, because this is on which functioning of siphon is linchpinned on. This is the fulcrum of our argument. If I want siphon to be operational, then P4 can maximum be, or I'll say not maximum, taking the other dimension, P4 can be reduced but cannot fall beyond 0, correct?
Yeah. Yes, sir.
P4 you can reduce. Why? Because P4 depends on H1, H2, right? Yeah.
Yes,
Yes,
sir.
sir.
P0 is constant, we all know. So H1, H2 it depends on, and H1, H2 is your take, completely your prerogative, what you want to. Yes, we are to make siphon operational, and siphon will be operational till the time P4 is positive or is minimum 0. Please write that down. For it to be operational, P4 can go to a minimum value of 0. Is it okay?
Yes, sir.
Yes,
And
sir.
if P4 goes to minimum 0, then H1 plus H2 maximum we will get, correct, dear?
Yeah.
Yes,
Yeah.
sir.
Yes,
Yes,
sir.
sir.
P4 is 0, then for that value 0 of P4, we get maximum of H1 plus H2. Please see for yourself. Equation is there with you.
Yeah. Yes, sir.
Are you
Yes,
getting
sir.
it? What I'm trying to suggest?
Yes,
Yes,
Let me,
sir.
sir.
let
Yes,
me
sir.
write this down. P0 minus P4, right, dear?
Yes, sir.
P0
Yes,
minus
Yes,
sir.
sir.
is what to you? Is rho g H1 plus H2. All of you agreed?
Yeah. Yes,
Yes,
sir.
sir.
Fine,
Yes,
dear?
sir.
Now, I want H1 plus H2. I get H1 plus H2 as P0 minus P4 by rho g, correct?
Yes, sir.
When will H1 plus H2 be maximum?
Sir,
When will, or what can be the maximum value of H1 plus H2 for siphon to function? Come on, tell me.
The P naught by rho G.
P naught by rho G. Why? For siphon to function, we at most should keep P4 equal, minimum, not at most, we minimum should keep P4 equal to 0.
Yes, sir.
Okay, so that is what we are going with. H1 plus H2 maximum we get from here class, write down. For siphon to be operational. Okay, H1 plus H2 maximum should be equal to P naught by rho G. P naught by rho G. Am I clear to all of you?
Yes, sir.
Yes, sir.
So this is the case with us. We are getting the maximum. Now, few questions as I've told you I'll be asking. Let me ask you on few of them. And also, by the way, H1 should also be greater than 0. H1 plus H2 should be less than P naught by rho G. And H1 should be greater than 0. That is an obvious, right, dear?
Yes, sir.
Yes, sir.
H1
Yes, sir.
must be greater than 0 for siphon to be operational. H1
Yes.
must be greater than 0, right, dear?
Yes,
Yes,
sir.
sir.
Okay. Now, a question which is into coming. Let me be an ask on it. Water was flowing and flow was maintained. What I do, I cut siphon at position 5.
Yes,
Is it
sir.
okay? I cut siphon at position 5. Now, if I cut siphon at position 5, then I may get water A still flowing or B water ceasing to flow. Is it okay? Two situations, correct? Yeah.
Yes, sir.
Water will continue to flow, will continue to siphon out, or will cease to flow. What will you say? Water will keep siphoning or cease to flow? Water will keep siphoning or cease to flow. That is my first. I have cut it over here. There is no H2 to me. H2 is 0. If H2 is 0, what is your take on water flow? All of you, tell me here. Think about it. What will your take on water flow? Will water continue to flow or
So
will
I
it
would say
cease?
water will stop flowing.
Okay. And why so? Why? Can you reason it out?
The pressure
Because-
equilibrium will be attained.
Yeah.
Okay. Pressure equilibrium will be attained. Because mind you, I have not said anything on H2. What I have told you about is H1 will be greater than and H1 plus H2 will be less than. So I have reserved my comment on H2 as there was a question to be positioned. So I have removed H2 and we are of the opinion that water will cease to flow. Agree, all of you?
So 1 second, sir.
Yes, sir.
So 1 second, yeah.
Sure, sure. Take your time.
So I think it will flow.
It will flow.
Yeah, sir.
Yeah, it should flow.
It should flow, yeah.
Okay. So water will keep on flowing. Okay. Adesh is going with which one, dear? Flow or cessation? Flow or cessation,
One
Adesh?
second,
Sir, it will continue to flow.
Okay.
Yeah.
Yes, sir. Flow.
Will continue to flow. Again.
Yes, sir.
Okay. So water will continue to flow is what we are going with. And what can be the reason for the same, please?
Sir, because the if
Ah.
H2 is equal to 0, P4 is
Yes,
equal
yes,
to P naught minus rho G H1.
Mhm.
Yeah. So in that case also, P4 is still lesser than P naught.
Yeah. But there was a reason that I did cite Krish, and that was Earth is pulling it down, correct?
Yes, sir. And Earth will pull it down, sir.
There was some portion over here which was below this level, correct, Krish?
Yes, sir.
And on that additional weight, as Earth is applying force on it, on that additional weight, there will be a force due to upper part, and in accordance, there will be a force on upper part due to this part of it, this part of siphon, correct?
Yes, sir.
So I did not place it on. Did I position it vis-a-vis pressure? No. I positioned it vis-a-vis gravitational pull, correct, yeah?
Yes, sir. So, but then
But
in this,
if you are
in this
denuding
case,
that part, siphon off. You have denuded that part, siphon off. You have denuded, siphon off that part. Can I say that?
yes, sir.
We avoid siphon off the pull due to gravity. Yes or no?
Yeah, yes, sir.
If we have divided it, if this part is being removed, then what is the additional force? Is there any additional force to pull it down?
No.
Is there any additional force to pull it down? Think about it. It's not that I'm trying to appropriate words. I'm just asking that if I remove H2, why I'm asking because you have not tried this, or if you have tried, then you have not paid heed to.
Yeah.
If you will take the same level here and try to siphon liquid, it will never come out.
Okay.
Okay, you will have to keep on sucking it. Only then it can come out. So you are pumping liquid out. That is a different ball game altogether. But if you are to maintain level, then this should be down. This should
Yes,
be
sir.
below the level of liquid from where, or vessel in the
Okay.
liquid in the vessel from where you want to siphon it. Correct, dear?
There I got it. Yes, sir. Yes, sir.
If you will remove H2, dear, water will cease to flow. Liquid will cease to flow. Liquid cannot flow because liquid was flowing owing to gravitational pull. And gravitational pull on what? On additional part which is applying additional weight or pull to it. Correct? Yeah.
Yes, sir.
Yes, sir.
So if you remove H2, water will cease to flow. And with this understanding, if water is not over as yet, far from over yet, if water ceases to flow, then I get a level of water. That level will be flat, bulge this way, or bulge this way. My question clear?
Yes, sir.
5, I will see if I have cut it and water ceases to flow. Then I'll see level of water at 5. Advanced level question is there, or Olympiad. Very important. Then at 5, if I cut and water ceases to flow, what according to you should be level at 5 of water? Should it be in the form of water droplet this way, bulging out of 5, flat, or caved in? What it should be? It's a very important question, and you can very well. I am susceptible of this appearing in the examination sooner than later. Tell me, dear. 5 is now open to atmosphere. 5, this is the equation, P naught minus rho g H2. 5 is open to atmosphere. It is being cut. You've been asked what surface you are to see, bulge out, caved in, or flat. Anyone, please take the lead.
1 second.
Oh.
So will it be caved in?
Okay.
So I'm not sure, but I guess it will be caved in.
Okay. You can neglect V1 over here, and you can very well get a relation between P5, P0, and half rho V5 square. Or there is the other relation also between P5 and P0. So any relation as per what is to your suit, you can go ahead with. I'm writing both for you. This one, P0 plus half rho V1 squared. So I'm equating first equation with the last, not last, this one, is equal to P5 plus half rho V5 squared. And we know this can be neglected, right? Yeah?
Yes, sir.
Yes,
Because
sir.
V1 is moving with snail, this level is moving with snail speed. V1 is approximated to 0, correct? Yeah.
Yes, sir.
Yes, sir.
So you know between P0, P5 when it comes to V5, you know between P0, P5 when it comes to height H2. Everything is there with you. Now you are to join dots, put 2 and 2 together and get me an answer. The two answers which I have got being, it will be caved in. Yes, Adesh and Pratyush.
1 second. Sir, I don't want to give that as an answer, sir. I'll just think once more.
Okay. Are you ready? Fine. Please go ahead.
Sir,
Yeah.
I
What
think
Pratyush?
it will be convex in shape.
Convex means caved in you are going, right?
Yeah.
Okay. The convex will be caved out, bulged out.
Yes,
Which one?
yes,
Bulged
check it
out.
out. Yes, sir.
Okay.
So bulged out.
Yeah.
Call. Go ahead.
So,
Get it.
so it has nothing to do with the cohesive and adhesive force now.
No, adhesive force we are not taking into account. Don't worry. Adhesive cohesive we are not taking into account.
Okay, sir.
So will it be bulged out?
Okay.
Uh,
Adesh,
yes.
what?
Yes, sir, bulged out. Bulged out, I said that.
Okay, bulged out. Fine. So let us check now. What is pressure just above the mouth? P5, correct dear?
Yes, sir.
Yes, sir.
Just above the mouth. P5, as I've cut, there is no H2 to be seen. So just above the mouth, it is P5, right dear?
Yes, sir.
Yes, sir.
Yes, sir.
Just below the mouth
P0.
It's P note.
is P0. So which one is higher according to you? Because you all have taken a call. So which one is higher? Is P5 higher than P0 or P0 higher than P5? That is to decide on level, correct dear?
Yes, sir.
Remy,
Yes,
will
sir.
that not decide on level? Level or curvature of meniscus is also based or to reflect pressure, right dear?
Sir, it's caved. Sir,
Yes.
I'm sorry. It's caved.
Yes, sir.
As the reason last class when I was referring to, I made you understand by both the methodology. Because meniscus, whatever be the reason for meniscus, see, of course, adhesive, cohesive, they are part of it. But whatever be the reason of meniscus, it is to be in consonance with pressure below and above the meniscus. Correct, yeah?
Yes, sir.
Yes, sir.
Or if it is curved, then you are suggesting of one pressure being higher than the other, right?
Yes,
Yes,
sir.
sir.
So what is your take now? Final
So,
call.
so atmospheric pressure is higher and it will be caved in.
Right. Yes,
according
sir.
to me.
Caved in.
Okay. And what makes you say, Vedant, atmospheric pressure is higher?
So previously, where when there was H2 also, then we got an equation P5 equals to P
There
naught.
is no H2 now.
Yes, sir, but
There is no H2 now. See,
yes,
after
sir,
all
yes,
this much of deliberation also, you're not
yes,
coming to the right.
yes, sir, yes,
There is
sir.
no H2 now. And I wrote two equations. There is no V5 now either, correct?
Yes, sir, I know.
So, P5 is equal to P naught.
Yes, sir.
So what will you say about level now? Tell me, final answer now. Will
Flat.
it be bulged out? Will it be
So
caved in?
then flat, so then we flat.
Flat.
Be a flat surface, yes. Got all of you?
Yes,
Yes.
sir.
Yes,
It
sir.
will be a flat surface. Look from any angle of prism. V5 is 0, water has ceased to flow. H2 is 0, we have cut the portion off. In any case, P5 now equates to P naught. P5 just above the mouth and P naught just below the mouth. They are even. Therefore, surface that we are to get is ordained to be, tell me dear.
Flat.
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 Got it here?
Yes, sir.
If we cut here quickly now, without
Yes,
wasting.
sir.
If we cut here, this point, 7, tell me. If we cut there and water ceases to flow, if we cut there and water ceases to flow, how will I get the bulge? Curved in, curved out, what is your take? Hell yeah.
So it should be flat again.
Flat.
Then.
Yeah, flat.
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 Again.
Yes, sir.
Okay, let's see. Let's try to write first 7
It
first.
won't be flat.
So 1 second, sir.
All are changing your stance. What can I say, dear? Don't act a chameleon. Tell me one and stick to it.
So if we cut below the level, it will flow. Why will it cease to flow?
No, I said that will cease to flow. And then I'm asking. That's the reason I've added that word. No, it is not mandatory that it will flow, dear. It can cease to flow as well. Because height you are to maintain. Is it okay?
Yes.
H1 plus H2 you are to maintain. Fine?
Yeah, yes, sir.
Yeah.
H1 plus H2 you are to maintain. So
Yes,
you can
sir.
adjust it, and let's say that you have cut somewhere and now it ceases to flow. See, as it recedes, Vedant, you may
Yes, sir.
experience back your place.
Yes,
As the
sir.
level recedes, you have to keep on moving down. Have you ever?
Okay, yeah, yes, sir.
Right? Have you ever? Not these try back or wrong. If you want to maintain the flow, if you want to be maintaining in sustenance the flow, then you'll have to keep on moving down as the level is receding. Correct, dear?
I have seen my father. Yes, sir. Yes,
Yes,
sir.
sir.
So what we do, we adjust H2, right, Vedant?
Yes, sir.
So that is what I'm saying. Suppose you don't adjust H2. In a way, you are cutting it, isn't it?
Yes, sir.
So water will cease to flow, correct? So that has happened.
Yes.
Water has got a cessation. It is not flowing. If it is not flowing, then what should be the level? It should be bulged out, flat, or caved in. That is what the question is.
So is it bulged out?
Okay. Let's see for 7, Krish, right here.
Yes, sir.
P7 minus rho G H.
Prime.
Let's say 7 only. Fine.
Yes, sir. Okay.
Rho G H7. This is H7. Fine.
Yeah. 0.
And plus half rho V square right here. Half rho V7 square right here.
Yes, sir.
Yes,
Is
sir.
equal to what we can say P naught. Here I am taking next. Allowed?
Sir?
Which point?
P naught. So you can take first point. So P naught plus half rho V1 square.
Okay. So we can take this one. Right. Correct. P naught plus half rho V1, right? And then this is 0, right? Yeah.
Yeah. Even V7 is also 0. It's not flowing.
Yeah. V7 is not 0, Krish. V7
Yes.
is 0 because it has ceased to flow. Correct. Very
Yes,
That's
sir.
right. Yeah.
Yes,
Yes,
sir.
sir.
good. Right. So what do we get P7 as? P7 is more than P naught, correct?
Yes, sir.
And as it is more than P naught, what we will get to see, Vedant?
The
As we
bulk
say,
out.
bulged out.
The
Clear,
bulk
dear?
out. Yes, sir. Got it.
Yes.
Okay, dear. Clear this part. Siphon with question clear to all of you.
Yes,
Yes,
sir.
sir.
Okay, very good. What's the time?
So the time is 1:20.
1:20. Okay, I'll take one more question and then we'll call it a day. And maybe today I'll upload a few questions for you so that you can get through this. The portion that we are through, you can be through them and get me an answer to those. There can
The
be
question.
questions which will be amalgamation of rotation and fluid as well. Is it okay?
Yes,
Yes,
sir.
sir.
Okay, question that I want to take, write down all of them. The lower end of a pipe of length, small l, the lower end of a pipe of length small l is greater than, in the bracket, L is greater than 3h. In the bracket you write L is greater than 3h. Bracket close. Is closed and then dipped in. Is closed and then dipped in. Liquid such that is closed and dipped in. Liquid such that lower end of the pipe is at depth, is at depth H in liquid L2, H in liquid L2, and then is opened, and then is opened. Bracket open. Angle of contact of liquid L1 is 60. Angle of contact of liquid L1 is 60. And L2 is 0. And L2 is 0. Surface tension of L1 is 2T. Surface tension of L1 is 2T. And L2 is T. And L2 is T. Height to which, the question has been, height to which liquid L2 will rise from lower end of the tube. Height to which liquid L2 will rise from lower end of the tube is 3h by 2, 3h by 2, 3h by 2 plus T divided by R rho G. This is first option. Second option is h by 2 plus T divided by R rho G. Third option, both the liquids insert in the pipe. Means both the liquid get into the pipe. Both the liquids get into the pipe. Is it okay? This is
Yes,
the third
sir.
option. Both the liquid get into the pipe. Fourth option. Only liquid L2 gets in the pipe. Only liquid L2 gets in the pipe. Figure which it comes with is this. This is 2 rho L2. This is rho L1. Liquid 1, liquid 2, they're referring. Water is up to this level, let's say. For liquid, this one. This height is given to you, H. And this height given to you is twice of H. And then you have a tube, as they have indicated. Tube is of radius R and length M. Where L they have said is greater than thrice of H. And they have given you contact angles as well. Tell me, how will you go about it? This is an amalgamation of surface tension, capillary tube. So you should take time to solve it. For a few, the statements which I'm into making do hold water, but also doesn't for the other set. And the set no, which I'm referring to. Correct, dear? One set do have time. A set of people do have time. The other set of people, I doubt they do have any left with them. Right, Krish?
Yes, sir.
Okay, so we need to get done with whatever is there for us left for. Okay?
Yes, sir.
It's not that the one fine day you will rise like phoenix from the ashes of losses. Is that to happen, Krish? Huh? That is
No.
not to happen, right? Yeah, you're waiting for a day, that one fine day I will rise as phoenix from ashes of losses. Then it's a different ball game altogether. Whatever is to be done is to be done. Instead of flogging that horse, we need to get to ground and start what time we are left with making productive of it. Correct, yeah? Pratyush, it goes the same for with you, right? Yeah.
Yes, sir.
Okay. You have to see and let me rub it in. Let me rub it in. How harsh I may be, I don't know, but let me rub it in. It's only 7 months left,
Yes, sir.
right, Krish?
Yes, sir.
Only 7 months for January. Okay, tell me, dear, how will you go about it? Now we don't know water will rise to what height. We have to find water will rise to what height. But we are known to that we can draw FBD at any point in time, right? Yeah.
Yes, sir.
You can draw
Yes, sir.
free body diagram for the portion which is inside of tube, or for the portion of water which is inside of tube. We can draw free body diagram. Are you all in agreement with that or not?
Yes, sir.
Yes, sir.
So let me be and ask. Which liquid will go in? That is no brainer, isn't it? Yeah. Which liquid will go inside is no brainer. L2 will go inside, right? Yeah. L1 cannot. Correct? Yeah. Till the time
Yes, sir.
L2 has exhausted, L1 cannot be permitted an entrance. Say me yes or no.
Yes, sir.
So
Yes, sir.
L2 will go in. That is non-starter of a question. L2 will go in, and L2 goes up. L2 has got what contact angle there? Read it out.
Sir, 0.
0.
So L2 rises in it, and L2 goes to this shape. Now check. 0 means this. Contact angle 0 means it's a hemisphere. Correct? Yeah. Please be careful. Contact angle 0 doesn't mean flat.
Yeah, yes, sir.
Contact angle 0 doesn't Adesha miss this class, okay? You will refer to the recording. Contact angle 0, I have told we have studied about contact angle. Can you recollect?
Yes, sir.
Yeah, yes, sir, yes, sir.
So contact angle 0 means you will get the meniscus as half of the sphere, right, Krish?
Yeah, yes, sir.
Yes, sir.
So this is what we are getting as the meniscus. What is pressure over here? Pressure over here will be open to atmosphere as it is, so P naught.
Yes, sir.
Yes, sir.
Then what did they say? Up to what height is it being? What was the question? Something about height was mentioned. Up to what depth it is being lowered? H in liquid L2, right?
Yes.
H
Yes,
Yes,
sir.
sir.
liquid L2. So if I take this, this is what? Let me draw for the kids. If I take H in liquid L2, is it visible?
Yes, sir.
Yes, sir.
Okay. How much is this, dear? H as per the question?
Yes, sir.
Okay.
Yes, sir.
Then what will be pressure over here? Quickly. Pressure over here. This is H and this also H, correct?
Yeah, yes, sir.
So pressure over here will be how much? P naught is at the top plus rho 1
1 M.
G H, right here, down up to this
Yes,
point,
sir.
plus, tell me dear,
Plus rho 2
Yes,
GH.
sir.
The road to GH.
2, we can, fine, I'll write rho 2 first and then we'll change. Rho 2 GH, right here?
Yes,
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 sir.
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 Rho and rho 2 are related. So P naught plus rho GH and twice of rho GH, correct?
Yes, sir.
Yes, sir.
So P naught plus 3 rho GH, right there?
Yes, sir.
Yes,
Yes, sir.
sir.
Now on the liquid, then from here, what will be the force here? P naught plus rho 3 rho GH into area, semi yes or no?
Yeah, which is pi
Yes,
r
sir.
square.
Area of cross section, agreed here.
Yes,
Yes,
sir.
sir.
Yes, sir.
And from top, what will be is P naught into A
Yes, sir.
by A, area of projection, I have told you.
Yeah. Yes, sir.
So
Yes, sir.
P naught into A from top and P naught plus 3 rho GH into A from bottom. Okay, any other force acting on it? Yes, of course.
Yeah.
One is surface tension and the other is weight. Correct, yeah?
Yes, sir.
Yes, sir.
Yes, sir.
Surface tension will act and what will it be equal to? T multiplied with length of operation. Correct, yeah?
Yes, sir.
So
Yes, sir.
radius is R. Somewhere I wrote R. Now radius is given to you, correct?
Yes, sir.
Yes, sir.
So length to which it acts will be straight away written 2 pi r and there is no cos theta because cos theta is 1, correct?
Yes, sir.
Yes,
Yes,
sir.
sir.
Force is this way, correct dear? Think about it. Force is this way, not this way. Right?
Yes,
Exact
sir.
angle is 0, correct? So force is up, straight up.
Yeah. Yes, sir.
So T into 2 pi r force straight up, correct dear?
Yes, sir.
Yes,
Yes,
sir.
And
sir.
what is the force in the downward direction? Force in the downward direction, anyone? Gravitational pull, correct dear?
Yes, sir.
And
MG.
will
Yes.
there be gravitation? Think about it. Will there be
Yes,
gravitational pull or not?
Yes,
Because
sir.
yes, sir.
we have
Yes, sir.
written. Okay, there will be. So what will it be equal to? Tell me. What can we
Yes.
write? Gravitational pull equal to meniscus. If we are to generally, they will ask you to ignore loss of mass due to meniscus because meniscus is very narrow. Height may be large, height may be in good quantum, but meniscus is very narrow. So they go with cylinder unless stated otherwise. Is it okay?
Yes, sir.
Yes, sir.
Okay, we can remove mass as well. There's no rocket science. You know what is volume of half of sphere. So if so required, you can remove mass. But if it's not matching with option, then we will discount on it. Fine, dear?
Yes, sir.
Yes, sir.
Assuming it to be a cylinder, can you tell me what shall I write? Pi r
R
square, dear,
Yes, sir.
into h.
Yes, sir.
H means how much? What will be h equal to? H is the height to which water has risen in it. Correct, dear?
Yes, sir.
Pi r square h, which, by the way, be very careful over here. This is important here. Which portion you are writing equation for? Is that clear? Which portion? The portion which is inside of the inside
Yes.
of the capillary. Correct.
Yes, sir.
Okay. So writing
Yeah.
equation for the portion which is inside of the capillary. Clear, dear?
Yes, sir.
Yes, sir.
And you have written for pressure equation. What will be the weight of liquid in it, and which liquid has filled it, by the way? Which density? Rho1 or Rho2?
So root 2, L2.
So pi r square h, the height, which I don't know. Please don't compare it with capital H.
Yes, sir.
Getting it?
Yes, sir.
Yes,
Height we don't know.
Yeah.
That is what the question is positioned on. Up to what height it will rise. Correct, yeah?
yes,
Yes,
sir.
sir.
Yes, sir.
So that height being written is small h, and then multiplied with density to g. Correct?
Yes, sir.
Yes, sir.
Tell me the forces. This is known to you. This is known to you. This will be upwards. Correct, yeah? And this will be downwards. Right, yeah?
Yes,
Sir.
sir.
Now
Yeah.
tell me, which option will you go with? Quickly calculate, all of you. What will be the height from the end you are to take? Sometimes they will try to trick you, and please be very careful. They may ask, what is the height to which water rises or liquid rises? Are you getting it?
Yes, sir.
And
Yes,
they may
sir.
not get you from end. We have taken from end. So our answer, whatever we have to get h, that will be the answer. Suppose rise from this level was asked, then you will be subtracting from it h and h. Correct, dear?
Yes, sir.
Yes, sir.
Small
Yeah.
h minus twice of capital H. Getting it, dear? Don't fall for the tricks. Fine?
Yes, sir. Yeah.
Okay. Anyway, over here answer will be small h as they have specified from the end. Tell me which option is a match. Add them algebraically and equate to 0, correct?
Yes, sir.
Yes, sir.
The needful quickly, dear. Add algebraically and equate to 0.
Sir, will it be the first option?
Which one it is? What was it?
H
Read
by
it out.
2 plus 3h by 2 plus t r rho g.
Did
T
you
by
get
r
that?
rho g.
Did you get that?
No, sir. I got 3 by 2. That's why I just I asked that.
That's correct. That's correct. That's an intelligent guess, dear. That's an intelligent guess. That's true. But why not to look for what we are getting when we are this close?
No, sir.
Isn't it?
I just did that because this is the answer.
That's right. Absolutely right. What you have gauged on is good. I'm appreciative of it. But when we are this close, we should not take anything to chance, right, dear?
Yes, sir.
About 5 marks, right?
Yes, sir.
Okay. That guesstimation you can do if you are in want of time. So what will be the answer? As said, Krish, 3h by 2 plus t divided by r rho g. Correct?
Yeah, I got it.
Yes.
And the other option also is correct, which is L2 will, correct? L2 will seep in. Correct, yeah?
Yes, sir.
Yes,
So
sir.
A and D.
Yeah. Okay, then I have to keep to this today. Few good questions coming your way. Please fasten your seat belt. Find ya.
Yes, sir.
Yes,
Yes, sir. Thank you, sir.
Thank you.
Thank you, sir.
thank you, sir.